Hello everyone, welcome to the fourth Python tutorial, and today we're gonna dive into some advanced topics, so go for it slowly and in your pace, and I'm sure if you put in the effort, you can do it. So first of all, we're gonna talk about scope, and scope is basically a concept encoding what is used where, or what scope does something have. And specifically, we're gonna look at functions. And so basically you can think of the scope of functions like this set of stairs, and then you have one simple rule. The functions, they can see down, but not up. So if you're in the top stair, you can see all the other stairs, but you're in the bottom stair and you're just looking down, you can't see the ones above you, right? And then there's one important thing. Basically, you have a call stack with function. We're going to look at this in a second. And this is not necessarily the same as code nesting. So code nesting just means how your functions look in your code, but we're also going to look at this. But so how does this function see down but not up work? So basically you can think about it that this is the lowest one and it can only see down, so nothing. And this stairs can see one below and this one can see the other two, right? So this is just for illustration. And now, how does this call stack work? So imagine we have this code on the right. Have a look at it, just pause the video. But basically what it is just different functions which are going to call each other. And so this is our global scope, so to speak. So it's just the normal file flow. And this is going to be our base in the call stack. So what the call stack does, while you execute something or the file, it keeps track of where in the file are you. So right now you're in the global scope. So just a normal file flow. And as soon as you go into the function, it's going to create a new scope for this function. So this scope is basically just an area where you can store variables, for example, if you will so. It's probably a bit more complex than that, how it's programmed, but this is the idea of it. So now what would happen if you use first called, if you call this function, then we're going to go into this function, right? And now we're inside this block. And so we kind of have our own scope now. So we're going to put this on the call stack. So here we just use the name, but just think of it that the program execution, it keeps track of which function is being called. So in here, we're going to call another function. So we're now in this scope, and we're also going to put it on the stack, right? And from in here, we can do the same again. We can call another function, and it's going to put it on the stack as well. And now what's going to happen is basically it's going to execute this print statement in the third called function, and then it's going to return, right, implicitly. And so what's going to happen, it's going to go out of the scope and it's going to put it away from the call stack. And then it's going to execute the print statement from the second called function. So after this is executed, and then it's going to leave this scope as well because it's going to return, right? So what's going to happen? The second call is now also done. It's removed from the stack. And we're going to go one step further and doing the fourth called function. And now what's going to happen is it's going into this new scope of this other called function, the fourth. And then we're going to put it in the stack again. Now we're going to execute this print statement that's in there. And so you're going to get the output. And then afterwards, it's going to leave this scope as well because it's going to return. And it's going to pop it off the stack. So now you can see this is basically how it goes until it reaches the base again, and basically the program is done. So if you don't understand how this works, go to Python Tutor or just use the debugger in your IDE. This is a great way to get started. Try to really understand how this call stack works, because as soon as you're going to start debugging bigger programs, this is going to save you a lot of time and it's going to help you a lot. So how does now this code nesting work? If you have our stairs again, we can think about our functions as an example as these three lines, right? So we have the small child, which is going to be called Leia. We have Laura, the mother, and then we have Dexter, the dad. And now, as we've seen before, basically they always look down. And now you see Leia, she can't see anything below it, so she couldn't call anything, right? Then for Laura, she can see Leia is below her, so she can basically call for Leia. And then you have Dexter, and he basically can call for Leia and Laura. And so how I want you to think about it is that these 3 lions, they are variables. And basically where they are on the stairs, this is basically where their function is defined. So if you have a function on the same level as Dexter, the function can access Laura and Leia and Dexter. But if your function is on the step of Laura, then it can only access Laura and Leia, but it can't see Dexter, right? So now what would happen if you have another Laura? So we have 2 Lauras now, and they're both on the same scale. So the code doesn't allow you to do this because there only can be 1 variable in 1 scope at a time, right? You can't have the same variable twice. You can only reassign it. So she's just going to be like, yeah, there can only be 1 Laura and the other one has to go. So the code doesn't allow you to do this. But what can happen is that you have a Laura on different fields. And we're going to show you an example of this later. But basically what is important, if you have a Laura on the middle field and 1 Laura on the same level as Dexter, and the function is calling from Dexter basically, it's always the question, which one is he going to use? And so how this works basically, think about him visually or auditively calling out, and then his voice would go further and further, and it's going to reach the one on the same level first. So it's always going to use the one on the same level before it's going to use the one from the lower levels. So what does this mean? In our example, we can just replace these line names with functions. So we think of the lowest one as the global scope, and then we have a function foo and a function bar. So we can see it here in the code basically. What's going to happen? We're going to assign a variable called scoped variable 3 times. So the first one, it's here in the global scope. Then we're going to go into our foo function, and there we're going to give the variable the exact same name. So it's going to override it, so to speak. And we do it here again. So if you do this all in the global scope, then it would just save the last. So basically it will all be scope of bar, right? But since we're defining it in the functions, it's going to be in its own scope. So now we're going to execute the code. It's going to start here, right? So it starts with this foo, and it's going to call this function. So what's going to happen? In the function itself, it's going to assign the values and defining the function, and then it's going to call bar. And as we can see here, when we use print scoped variable, it's going to now check basically where is the scoped variable, and it's always going to take the closest one. So in this case, it would be this one, right? Because it's in the same function scope, so basically on the same indent. And now the function would return, and we go on. And now when we do this other print, you can now see it's basically in this foo scope, right? And what's going to happen, it's going to use this variable because it doesn't know about the variable of bar basically, right? This is what we had before with the stairs. And likewise, if we have this print scoped variable from the global scope, it doesn't know about the scoped variable in foo, and it doesn't know about the scoped variable in bar. So what's going to happen, it's going to use this global, right? And now think of this. What if we didn't have this assignment? So this would basically be the output. You wouldn't have the bar. You would just have foo twice. And what's going to happen here is basically if you use this print scoped variable, it's just going to go from the inside to the outside. So in this case, it's going to use this one, right? Because it's the first or the most close scope, so to speak. And basically this is how it goes. So what's important, if you print inside a function, it's always going from the most innermost to the outermost. So this would be priority 1, priority 2, priority 3. So this is how it's going to take the variable. And this concept is basically called shadowing, and we're going to look at it a bit closer later on. And in case you're still confused, please use this awesome tool called Python Tutor, and it's basically going to show you how it executes. So you can just copy the example from before, put it into Python Tutor, and then go through the steps, and you can go forth and back, and you can see how it works. And basically here on the left you can see the code, And on the right, you can see these different function scopes. So you can see we have the global frame where x is 0. And then inside foo, we have another x, and this is 1, right? So play around with this, and then, as before, try to delete some of the variables with the same name and see what happens, see how it works. And now we're going to have a look at the global keyword. So basically, this allows you to trick the usual function scoping, so to speak. So what's happening? Here we assign this global scoped variable. So what does it mean? It basically means we want to use this variable, scoped variable, we want to use it, but we want to use the global version of it. So we're going to do print scoped variable here. From what we've learned before, basically we would have to use this scoped variable, which is scope of foo, right? Because this is closer than the one that's assigned global. And now it doesn't use this one. And why is that? Basically because we use this global keyword. So the global keyword always wants to use the variable assigned in the global scope. And it's important, it's really looking for the global scope and not just reversing the order. So it's not gonna fall back to the scoped variable. So imagine this, if we don't have this, basically, if we just have the one assignment and we still use the global keyword, it's gonna give you one error. And why is that? Because it doesn't reverse the order of checking where should I find my variable, but instead it uses only the global one. And if you don't have it, it's gonna not find it and it's gonna throw you an error. So the concept that we now used basically is called shadowing. And so how this works basically, it's if you use the same name for a variable in local and global or lower local scopes, so to speak. So in this case, we have scoped variable assigned to global, and then inside the foo function, we have the same name again, and then in bar, we have the same name again, right? And so this basically what we talked about before, how it works with the access. And here important is it can only access the most local, so to speak, or it can use the global one with the keyword. But you can never use the local one and from a higher local or from a higher global or so. Maybe there's a workaround to make it work. Probably there is, but yeah, just don't do it. You're going to confuse yourself and others. If you really need both, just use a different name, right? So basically, if you use the same name, you want to replace it in the function. So a quick note on classes. Basically, what do we use them for? So the idea with classes is to represent objects from the real world. So if you remember our cow, which we had previously as an example, basically we have different characteristics of it, such as the name or the color. And then in a class, you always, or often, you also have behavior, which would be, for example, for a cow to make moo, or you can milk it, and then you're gonna get some milk. And basically there's two things for it. So this name, color, and so on, these are called class attributes in Python. They're always, in some program languages, they're called different, but in Python, they're called class attributes. And so basically they're just the information about this object. And then you also have methods, and the methods are basically functionality of this object. So you can think of it, how you can think of it is attributes are how is the object, and methods is what can this object do. So in code, this is how such an object would look like. In this case, we have just a person, which is defined and has a name and age. So basically here, you could see these attributes. Don't worry now how exactly the syntax looks. You're going to learn this in class. But basically here we define, for example, a name and age. And then here we would have a method, which is just going to return a string. And down there in the code, you can see how we would create such an object. So we say front, which is going to be our variable name, and then we're going to say or write out the class name and then use these brackets to instantiate it. And the instantiation basically happens with this constructor, which is done with this underscore underscore init and then underscore underscore, whereas init stands for initialize, and basically it's going to give you a new person object. And as soon as you have this object, you can access the methods or the functionality by using the variable name and then a dot and then just call the method. And so in the bottom right, you could see what would happen if you execute this code, and it's just going to print the name of this person is Franz, because his name is Franz, right? And then now we have to talk about one small concept, which is magic methods. It sounds really confusing at the beginning, but as soon as you get the concept, it's actually rather simple. So how does this work? Basically, if you now have a class, you might want to use methods which you usually use in your code. For example, you have this print function, right? And now if you're going to try this in your code and play around a bit, then you're going to notice if you say print this Franz, which is a person, then you're just going to get this weird thing in the output, which is then main person object at some random number. And this is basically the default behavior if you want to print one of your own objects. So it's just going to give you the memory location. And what are you going to do with this? It's not really helpful. So Python invented a cool thing, which is this magic methods. And they want to make basically your life easier. And you can see in this code, when you use the print Franz, in the output, you're going to get something way nicer. This person's name is Franz, and the person is 50 years old. So you're going to get some actual information which you can use when you want to print something. And how does this happen? Basically, when you say print an object, then how the print function works, it's going to check, does this object have a way of representing itself so I can print it more nicely? And basically how this is done, it's going to search for a specific method, which is called underscore underscore wrapper underscore underscore. And so these underscores in the front and the end, these are basically indicating these magic methods. And how they do it, they're just going to look through the object. And wrapper, in this case, stands for representation, and what it wants is basically to give you back a string. So the print function takes the object, and then it looks for, do I have this representation function? If I have it, then I use it. If I don't have it, then I'm just going to print the memory address. So what you need to take home, basically you have magic methods, and these are a function in this object. So it's a method in the object, and it's going to be used by functions such as the print. And so basically this print function then searches for this magic method, and if it has it, it's going to use it, and if not, then not. And now your question might be, why would I even use it? Because we have seen before, you can also just make your custom method, right? But basically here, the question is why, and the answer is it's just convenience. But not only convenience, but it also makes your code easier to understand. For example, it's with for loops you can use on a list. And the list is also just an object in the end. And you can basically define a magic method for your objects, which are then make it possible to use a for loop on your object. So if you're curious for this, try to make two classes. One class would be a person class, like here. You can also do it simpler. And then make a class which is called person collection. And in there, you can have like a list of multiple persons. And then try to extend this person collection class with magic methods, such that in your code then you can basically then do this, which is for person in person collection. And then the person should be all the person objects which are in your collection. So basically just if you do, it should basically work the same as you do for element in list. Then you're going to get each member of the list, right? And this you can implement yourself. Just try it out, Google it, and in the documentation, you can find it. And if you don't get it, ask ChatGPT and then do it, but still do it with the documentation, so you learn something. And so here will be all the sources that we used in this video, and see you in the next one.